are going to know about Nmr Lab Safety. Introduction about Nmr. Nuclear magnetic resonance, Nmr, was first detected experimentally in 1945. As a result of their research in Nmr spectroscopy, Bloch and Purcell were jointly awarded the 1952 Nobel Prize in Physics. Nmr spectroscopy involves the study of molecules by observing the interaction between radiofrequency electromagnetic radiation and the nuclei of molecules placed in a strong magnetic field. Nmr instruments utilize a static magnetic field to align nuclear spins. Magnets with varying strengths ranging from 1,500 to 200,000 Gauss, 0.15 to 21 Tesla, are used. The techniques used for Nmr spectroscopy are as follows. 1. Resonant frequency. This refers to the energy of absorption and the intensity of the signal, which is proportional to the strength of the magnetic field. Nmr active nuclei absorb electromagnetic radiation at a frequency characteristic of the isotope when placed in a magnetic field. 2. Acquisition of spectra. When the sample is excited with a radiofrequency pulse, a nuclear magnetic resonance response is obtained. This response is very weak and requires sensitive radio receivers to pick it up. Instrumentation in Nmr. Sample holder. The sample holder is a glass tube that measures 8.5 cm in length and 0.3 cm in diameter. Magnetic coils. These coils generate a magnetic field when there is a current flow through them. Permanent magnet. The permanent magnet ensures a homogeneous magnetic field at frequencies ranging from 60 to 100 MHz. Sweep generator. This generator modifies the strength of the already applied magnetic field. Radio frequency transmitter. This transmitter produces a powerful but short pulse of radio waves. Radio frequency receiver. This component helps detect the radio frequencies. RF detector. The RF detector aids in determining the unabsorbed radio frequencies. Recorder. The recorder records the Nmr signals received by the RF detector. Readout system. This system is a computer that records the data. Applications. Nuclear magnetic resonance, NMR, spectroscopy is an essential analytical tool for organic chemists, significantly improving research in the organic lab. NMR not only provides structural information about molecules but also determines the content and purity of samples. Among organic chemists, proton, 1H, NMR is one of the most widely used methods. Due to the varying chemical environment, the protons in the molecule exhibit distinct behavior, allowing for the elucidation of their structure. Working method. To perform a nuclear magnetic resonance, NMR, analysis, follow these steps. Begin by placing the sample in a magnetic field. Use radio waves to excite the nuclei sample, generating NMR signals. Detect these signals using sensitive radio receivers. The intramolecular magnetic field surrounding an atom in a molecule alters its resonance frequency. This alteration provides valuable insights into the molecule's functional groups and electronic structure. NMR spectroscopy serves as a conclusive method for identifying monomolecular organic compounds. Additionally, this technique offers information on the reaction state, structure, chemical environment, and dynamic behaviors of the molecule. The main safety concerns regarding NMR include the presence of a large magnetic field that attracts ferromagnetic objects, the potential for cryogens to cause burns when they come into contact with the skin, the risk of oxygen depletion leading to asphyxiation. To manage safety in NMR, the following measures are recommended. Operating according to the system's manual, conducting risk assessments, and implementing standard operating procedures for NMR handling. Displaying safety instructions, maintaining an authorized persons list, and using warning signs. Providing safety training on system operation. Regularly performing inspection checklists to identify and address potential safety issues. Ensuring safety data sheets are readily available for all chemicals used in the NMR laboratory. Reporting any spills, injuries, incidents, or contact with cryogenic materials. Handling NMR solvents, unwanted samples, contaminated broken glass, and other regulated waste materials with care by transferring them to the appropriate waste disposal system. Do not allow any metal items such as hand tools, gold or silver ornaments, ATM cards, or other chip cards in the lab. Only authorized personnel are allowed access. The 5 Gauss exclusion zone is marked by hazard tape on the floor. Always observe the 5 Gauss line indicated by the plastic safety chain, hazard tape on the floor, and other laboratory signage. EHS recommends that NMR end users remove personal items such as watches, jewelry, cell phones, and bank cards, and leave them beside the computer station before approaching the magnet. Individuals with medical implants such as pacemakers, biostimulators, neurostimulators, aneurysm clips, or surgical clips should not enter the NMR laboratory, as these implants may react to the magnetic field or be subject to the magnet's attractive forces, resulting in injury, device failure, or even death. Ensure that only trained individuals handle the NMR and its accessories according to the required process. Cryogenic hazards and safety measures. Evacuation is necessary when there is a loud noise from escaping gas and clouds of vapor. If a liquid nitrogen container ruptures and releases a large volume of nitrogen gas, the laboratory must be evacuated. Neglecting to refill or de-energize the magnet, indicated by cryogen level sensors, may lead to magnet damage due to a magnet quench. If the low-level warning lights on the sensors are continuously on and warning messages are displayed on the BSMS instrument panel, immediately inform the NMR facility staff. Cryogenic liquids are extremely cold and can cause severe burns if they come into contact with the worker's skin. Adequate personal protective equipment, PPE, must be worn when handling cryogens, including closed-toe shoes, a lab coat, eye protection, safety glasses, goggles, or a full-face shield, and cryogenic gloves. Oxygen depletion hazards and safety measures. An oxygen monitoring detector equipped with an alarm and light should be installed in the room. Occupants must immediately exit the lab when the oxygen alarm sounds. Re-entry into the room is prohibited until oxygen levels are confirmed to be normal. In the event of an NMR quench, vacate the lab without delay and promptly notify the NMR program manager. An airline respirator must be readily available in the room for use during emergencies. Emergency life breathing apparatus, ELBA, should be accessible near the NMR lab for critical situations. Electrical hazards and safety measures. Ensure proper arrangement of electrical wiring and fittings. Provide adequate earthing to equipment where necessary. Maintain suitable illumination levels in the room. Install instruments and accessories securely according to design specifications, ensuring they are user-friendly. Remove any slip, trip, or fall hazards within the lab area. Verify that the room's exhaust system is capable of expelling gases such as nitrogen and helium effectively. Individuals operating NMR equipment must receive proper training and authorization from the NMR program manager. Access to electrical panels or instrument consoles is restricted to authorized personnel only. Report any water accumulation on the floor of the NMR lab to the program staff immediately. Handling and safety of NMR tubes. Handle NMR tubes with utmost care as they are fragile and prone to breaking. Be aware that NMR tubes can contain a variety of solvents or materials, some of which may be hazardous. Detailed handling procedures for NMR tubes in research are outlined in the Laboratory Standard Operating Procedures, SOP. If a tube breaks and contains non-hazardous materials, the NMR program staff is responsible for its cleanup and disposal. For broken tubes with hazardous contents, consult the Environmental Health and Safety (EHS) department for proper cleanup guidance. Dispose of all broken NMR tubes in a designated puncture-resistant waste container to ensure safety. Emergency Response Protocol. Upon hearing the oxygen alarm or observing an NMR quench, evacuate the laboratory immediately and promptly notify the NMR program manager and the safety team. Do not re-enter the room until oxygen levels are confirmed to be normal. Emergency response teams, ERT, and safety officers must assess the situation by looking through viewing windows to check for any individuals requiring assistance within the lab. Safety officers are cautioned against entering the lab while the alarm is sounding and the orange strobe light is activated outside the room. In specific scenarios, opening the door may be necessary to facilitate rapid dissipation of inert cryogenic gases. During an emergency, immediately call the designated emergency numbers for assistance. If a fire extinguisher is needed, use only those designated for carbon dioxide to prevent damage to equipment. General safety instructions for NMR operation. Please refrain from eating or drinking in the laboratory and never work alone. Keep metallic objects away from magnets. It is best not to bring them into the lab at all. Magnetic media, mobile phones, and analog watches must be kept away from the magnet area. Only individuals who have received training from facility staff and follow official procedures may conduct cryogen fills. Safety gear is compulsory. Gloves, eye protection, and closed-toe shoes are required. Steel caps are not permitted. To ensure proper ventilation, keep all doors open. Use only stainless steel transfer lines to prevent cracking or magnetic attraction issues. Any tanks on wheels must either be chopped, held by another person, or securely transported using purpose-built trolleys. If an NMR quench occurs or the oxygen alarm activates, evacuate the lab immediately. An orange strobe light situated in the hallway outside the lab serves as a visual indicator. If it illuminates, this signifies an oxygen-deficient environment within the NMR facility. Transport all samples to the NMR lab in leak-proof secondary containers to prevent spills. Label NMR tubes, tube holders, and racks in accordance with the sample labeling requirements. Report any spills, injuries, incidents, or contact with cryogenic materials to the Environmental Health and Safety Department promptly. This is all about today's topic. Thanks for watching Funny EHS Info. And don't forget to subscribe our channel to get immediate notification of our videos. Share our videos to your friends and colleagues to create safety awareness. If you have any questions and requirements, please comment in comment box.